All right, guys. I am now beginning um, Unit 9. And Unit 9 is comprised of indicators 31 and 32. So indicator 31 is all about volume using fractional edge length as well as the formula. And indicator 32 is all about surface area. Okay, so if you will look at the learning target, I can identify the appropriate size for the unit cube based on the fractional edge lengths of the prism. I can calculate the volume of right rectangular prisms with fractional edge lengths using unit cubes and the formula. Okay, so basically volume is always for a three-dimensional shape. Okay, and if you can see, we are mostly calculating a rectangular prism, but I also want to show you other three-dimensional shapes. And if ever you were given an advanced question as to what is the volume of a, pyramid or a prism or a cylinder, you'd be able to explain as to why the volume differs for others, because it depends on the base of that three-dimensional shape. Okay, but a rectangular prism, it is nothing but, this is a square prism. Okay, but rectangular, it would just have a rectangular base. So it is a three-dimensional figure that has 6 rectangular sides. Okay, so square prism, in a prism, the base and the top are exactly the same. So that is the thing about a prism. Okay, you can have a triangular prism. Triangular prism means that your base will be triangular and the top will be triangular. Think about a tent, for example. That is definitely a triangular prism. And I'm going to get into more of this when we do indicator 32. Okay, and volume, it is the measure of the amount of space that it occupies. So how much can fit inside? Okay, this whole thing. Think about a swimming pool. Think about an aquarium. Think about your suitcase. So basically it is the base, the area of the base times the height. So that gives you volume, because that's how many clothes you can fit into your suitcase. Okay, the area of the base. Think about in a plane, when you have the carry-on bag, it is way smaller than your checked-in baggage, because the checked-in baggage, the base is much bigger and then it is deeper, or the height is more. So you can fit more stuff into your carry-on luggage compared to your one that you are taking with your hand baggage, where the base is small. So the area of the base times that height, whatever you can fit in there is going to be less. Okay, and volume is measured in cubic units. So please remember, like when we had done area, it was in square units. It was a number of square units inside a shape. In this, and remember, because area also is for two-dimensional shapes. So that is why for area we have square units. Volume, it is three-dimensional shapes, because they also have depth now. So that is why it is cubic units. So this is a prime example of a square prism. All right. There are so many different shapes. And this is a square, because you always look at the base to identify what kind of a three-dimensional shape it is. So this is a square, and this is a pyramid, because it is going up and tapering to the top. Okay, if it was a prism, it would have had the same, just like the base, it would have had the top. So that's the difference between a prism and a pyramid. Okay, pyramid has a base, but the top tapers like a mountain peak. Okay, then this is a cylinder. Okay, this is a cylinder. These are all three-dimensional shapes. This is a cone, and I know you're well versed with a cone. Okay, ice cream cone. All right. This is a sphere. Please don't say circle, because circle is a two-dimensional shape and a sphere is a three-dimensional shape. Okay, so just giving you a quick input about the different shapes. That we have a lot more, but I will cover that when we go to indicator 32. All right. So let's look at some of these pictures I have drawn over here. And literally, how do you find the volume? There are two ways. If something like this is given, it is pretty easy, because either you can count the number of cubes in that, just like in the square, when we did area, you could count the number of squares inside, or you could use a formula of length times width. In volume, because we also have depth, you have the base, which is the area of the base, which is length times width, and then we also have the height. Okay, so those are the three things to consider: length, width, and height. So the volume of a rectangle is length times width times height. Please remember, the length times width, it is pertaining to a rectangular prism. Okay, so let's look at this, whether that volume will, the formula will apply, as well as counting the cubes. Okay, so let's count the cubes. Either you can count the front, or you can count the top, and then we have so many layers. So let's say I can count the front. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 in this first layer of cubes. Okay, that is this. This is the layer, because it's three-dimensional. Okay, so that's what I want to show you. So I have 8 in this first layer. Then I have 8 in the second layer, because I can't see it. It's at the back. And then I have 8 in the third layer. Okay, so I can just do 8 plus 8 plus 8, or 8 times 3, and I will get 24 cubic units. Or you write unit cubed. Okay, because that's a cubic unit. All right, so this is how you can definitely calculate, by either counting the number of squares, or we can also do this. Okay, we can do, look at the base over here. Okay, so we have 1, 2, 3, 4, that's my length, times 1, 2, 3, that is 4 times 3 is 12. So I just found the area of the base, didn't I? Okay, length times width, because it's rectangular. And then times the height, which is 1, 2. Height is 2. So then 12 times 2 gives me 24. So I could have used the formula, found the area of the base times the height. My length is 1, 2, 3, 4, times my width is 1, 2, 3, times my height is 1, 2. So therefore, this also gives me 24 cubic units. So you can write cubic units, or you can write unit cubed. Okay, so let's look at this one now. Again, I can do, count 1, 2, 3, 4, 5, 6 times, this is one layer, this is the second layer. So that means my answer is 12 unit cubed. Okay, I can also do length times width times height. So look at my length. This is 1, 2, 3. Okay, width 1, 2, times height 1, 2. So 3 times 2, 6 times 2, 12. So I get 12 cubic units, or 12 unit cubed. You will still end up with the same answer. So I just wanted to show you either way, whether you're counting it or whether you're using the formula length times width times height. Okay, now the reason why I was saying you find the area of the base times the height. So look, let's do this. Let's look at the area of the base. This, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this whole thing is 10. All right. Over here, my width is 1, 2, 3. So my width is 3. Okay. Or I could have done 10. And into 3 layers, I get 30. So basically, either you're counting that, or you're doing the area of the base, which is length times width. So 10 times 3, and I get 30. And then let's say this height was 4. So it would be area of the base, which is 10 times 3, 30, times 4. And I would end up with 120 unit cubed. Okay, so I'm just going to show you this visually. This basically means I have 3 layers of 10 like this. 3 layers of 10 like this. Okay, and it's flat, so you can't see the back. So don't think there's nothing at the back, because there is. You just can't see it. Okay, so I have this, and then I have 3 layers of this, and then 4 more, it's going up. So you have 1, 2, 3. Okay, and then this is the second layer. This is my third layer, and then here comes layer number 4. So if you see this, look, this is what it looks like. Okay, so this is 4 layers of 10. If you take this, and then if you look this way, it's 3. Okay, so I would do base is 10 times the 3, that's 30, times the height, 1, 2, 3, 4, and that's what gives me 120. So I literally just showed you a model of what I just drew, and that is why if you are given the base of an object, the area of the base, and then you are given the height, you can straight up do the base times height, because that's basically what volume is. Think about a swimming pool. If the base is rectangular, you would do length times width times the height. If the base is triangular, you would do base times height divided by 2, because that's the base of a triangle, the area of a triangle, and then times the height, because whatever fits in there is determined by the base of the object. Okay, so let me take you, because now we are going to talk about fractional edge length. Okay, so I'm going to talk about fractional edge length. I just want to show you this once again. Look how sometimes you can't really see. I'm trying to get this further or closer, trying to see that you can see the whole thing. But this is what it looks like when you're counting cubes, because this is your box, and you have the bottom, and then you have the top. Okay, and so you the base, the area would be 4 times 3, which is 12, and then you have the 2 layers, and so that makes it 24. So I want to show that to you. Okay, now let's talk about fractional edge length, and this is really easy, and I know that you've never seen this before. Let me show this to you once again really quick. This is what I just showed you. You know why? The area of the rectangle, that is, see how this goes into the base over here? And then just so that you understand what I was just drawing earlier. So you find the area of the base, which is length times width, and that was this 10 times 3. And then if you have the height like this, that would be 4 more, that would fill up. And so that gives you the volume of the shape. Area of the base times the height. Area of the base times the height. Always remember that, okay? So I am going to show you fractional edge length. And this is something that you may have seen before or not. I don't know. But if you haven't, that's okay, because I am going to make it very easy for you right now. Okay? So look what it's saying. It's saying find the volume of a rectangular prism with fractional edge lengths if one cube, if just this one cube is going to be ½ inch. So fractional edge lengths is using these ½ inch cubes, okay? There are 2 ways to do this, and I don't care which one you choose, whatever works for you, all right? So I'm going to show you both ways. One way is you find the volume of 1 cube, okay? And we know volume is length times width times height, okay? So let's find the volume of just this 1 cube, okay? 1 cube is how much? What is the volume of that? So this is ½ inch, so length is half, width is half, and height is half. Okay, so when I multiply this, volume of 1 cube, 1 times 1 times 1, 2 times 2 is 4, 4 times 2 is 8. So 1 cube is 1/8 inches cubed. Okay, that is just this 1 cube. But look how many cubes I have in here. So I have to calculate the volume of that 1 cube times however many cubes are in there. Okay, because this was the volume of only 1 cube. So now I count. I can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 is just the front. So 36 cubes in the front layer. But let's see how many layers there are. This is layer 1, 2, 3, 4, 5, 6. That means each layer has 36 cubes. So I'm going to do 36 times 6. And 6 times 6 is 36, carry over 3. 6 times 3, 18, and plus 3, 21. So I have total number of cubes is 216. Total cubes are 216. Okay? So now, since the volume of 1 cube was 1/8, then what would the volume of 216 be? It's like saying 1 t-shirt was $5. How much will 10 t-shirts be? You would do 10 times 5, right? So same thing here. If the volume of 1 cube is 1/8 inches cubed, the volume of 216 cubes would be 216 times 1/8 in order to solve this, okay? And then I can definitely simplify before I multiply. So if I write this over 1, it's a fraction, remember? And so if I divide by 2, because both are even numbers, okay? So this would become 4. And then this would be, if I do by 2, I would get 1, and I would get 0, and I would get 8. Okay, because this would not go. So 2 divided by 2 is 1. 1 cannot go by 2, so 0. And then 16 is 8. Let me simplify even further. Okay, again, I have 108 and I have 4. Both are even numbers. So I'm going to simplify. And I would still get 2 over here. And I would get 54 over here. All right. Now, they're still even numbers, so divided by 2, I get 1. And here I get 27. So my answer for this volume is 27 inches cubed. As simple as that. If you choose to take 216 and then divide that whole thing by 8, you are free to do that with division. But you will still end up with 27 inches cubed. So this is one way to do it, finding the volume of 1 cube and then counting how many cubes they are and multiplying that 1 cube with all the cubes in order to find out the total volume. Now, let me show you another way. So I'm going to use a different color so you can see this other way, okay? So let's say I am going to take each of this as 1/2 because that's what this is, right? So this is 1/2, 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 this is 1/2. We know 2 halves make a whole. So look, this is 1 whole, this is 1 whole, this is 1 whole. So that means 1, 2, 3. So this is going to give me 3 of these, 3 wholes. Okay, now let's look on this side. We have half, 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 because that's what each edge length is, 1/2. Again, these two are 1, 2, 3. So we have 3 here. Then let's take the height. Again, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2. So this is 1, this is 2, this is 3. Now, volume, length times width times height. We have 3 times 3 times 3. That gives me 27 inches cubed. So here is the other option of how to find the volume of a shape of a three-dimensional prism if your fractional edge lengths are given. Okay, so let me show you one more example so that you understand what this is. And I am going to let you see this one. And I have worked it out for you, but I am going to walk you through this. All right. So in this one, it is asking again to find out the fractional edge length. Again, you can do this two ways. You can find the volume of 1 cube first, okay? And volume is length. This is 1 cube, okay? For 1 cube. And then we'll have to multiply that with how many cubes they are. So volume is 1/4. So 1/4 times 1/4 times 1/4, okay? And so that means 1 times 1 times 1 is 1. 4 times 4 is 16. Times 4 is 1/64. Centimeter cubed is the volume of 1 cube. Okay? In order to find out the volume of all the cubes, we could do, again, you can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 times, we can do the length times width times height to see how many cubes there are. We can also do it that way instead of sitting and counting the different layers. I mean, you're welcome to do it that way. If you did that, you would do 10, 20, 30, 40, and then times, well, this is 10, so this is 20, this is 30, this is 40, and this is your first layer, second layer, third layer, fourth layer. And you would do 40 times, you would do here 4, you get 120, and that's how you would use that number. Or you can do 10 times 4 times 4. Okay, so that is another way. And so I'm just going to do the 10 times 4 times 4. This is the volume of all the cubes. 10 times 4 times 4. Okay, and when I get this times the volume of 1 cube. Okay, now you can first multiply this and then simplify, but I would highly suggest trying to simplify before you multiply. Okay, but you're welcome to do 4 times 4, 16, times 10, 160, divided by 64. You will still end up with the same answer. But I'm going to simplify because remember these are fractions. I can make it over 1. And then times divided by 2, I get 5. Divided by 2, I get 32. Okay. Then divided by 2 again over here, I will get 2 and I will get 16. You can keep simplifying. Okay. By 4, I get 1. And then I would get over here 4 times 4 is 16. Okay. Then 1 times 2, 2 times 2 is 4. So what do I end up with? 5 times 1 times 1 times 1, which is 5, over 2, which is nothing but 2 1/2 centimeter cubed. So you can do it this way, 1 cube and then times how many cubes there are, or I am going to say each of these is 1/4. So I know that 4 of them is going to make 1 whole because 1/4, 2/4, 3/4, 4/4. Okay. So look, 1, 2, 3, 4. So this is 4/4, which is 1 whole. And then 1, 2, 3, 4. That gives me another whole. And then I have 1, 2. So this is half because 1/4 plus 1/4 gives me a half. Okay. Now, So this is 2.5 because this was a 1, sorry. And so this is 1 plus half, that is 2 1/2, and I'm finding the volume is equal to length times here 1/4, 1/4, 1/4, 1/4. This 4 of them becomes 1 whole, and then again 1/4, 1/4, 1/4, and 1/4. 4 of them make 1 whole. So then 2.5 times 1 times 1, and that ends up with 2 1/2 centimeter cubed. So as simple as that. So either you can use this way or you can use this way. It doesn't matter. When you're using fractional edge length, you will end up with the same answer. So again, find the volume of one cube and multiply it with how many total cubes they are. Or you can find based on the fractional edge length and then multiply that. All right. So this is volume. Now it is the space that is occupied. The amount of space that is occupied by a certain shape, and that's what volume is. Okay. Always think about your suitcase. All right. So tomorrow we will do surface area and we'll get more in depth into that. All right. Have a wonderful day.